Hi, Mr. Miranda here. On this video, I'll correct the Physics IGCSE 0625 Astronomy Specimen questions released by Cambridge. These are subdivided in multiple choice, so I'll correct first paper 1 core and then paper 2 extended multiple choice questions, and then I'll continue correcting papers 3 core and paper 4 extended free response questions. You can find a PDF with these questions and many other resources, namely all exams released by Cambridge since 2002, on my website, mrmiranda.online. Question 1. The diagram represents the positions of the Earth, the Sun, and the Moon at different times on the Moon's cycle. Which diagram represents the position of the Moon when a full moon is seen from the Earth? In order for you to understand how these questions are answered, you need to understand how the different phases of the moon are seen from the Earth and the relation that these have to the position of the moon in relation to the sun. I'm going to draw here at the center all possible positions that you have here on this diagram. So let's say that this is the sun, this is the Earth, and now I'm going to put the moon on position A, position B, position C, and position D. If you see the sunlight coming from the left to the right, obviously the side of the moon that is going to be lit on this diagram is always going to be on the left. This is also true for planet Earth. Okay, so on planet Earth, on the left hand side on this diagram, it will be daylight. On the right hand side, it would be night. On position A, people on Earth looking up, they would see this side of the moon. So they would see the full moon. You already know the correct answer. It's A. Just to make sure, let's look at the other possibilities. Position B, people looking up would see only half of the moon being lit. Position C, people on Earth looking up, they wouldn't be able to see the moon at all. Facing the Earth, it would be the dark side of the moon. Position D, people looking up would see again only half of the moon being lit. So, full moon, position A. Question 2. Which row correctly describes the nature of Mars and the nature of Saturn? You need to know that Mars belongs to a set of planets that are closer to the Sun. These are called, appropriately, the inner planets. Saturn belongs to the other set of planets, the ones that are further away from the Sun, and these are called the outer planets. What are the inner planets? In crescent order from the Sun, it's Mercury, Venus, Earth, and Mars. The outer planets are Jupiter, Saturn, Uranus, and Neptune. Dividing them, you have the asteroid belt. The planets in each one of the sets, they have completely different characteristics. The main differences are that the inner planets, they are much smaller than the outer planets, and the inner planets, they are also rocky, they have a rocky surface, and the outer planets are gaseous in nature. So this provides the correct answer. Mars is a rocky planet, this eliminates A and B, and Saturn is a gaseous planet, this eliminates D, so the correct answer is C. Which type of force keeps the planets in orbit around the Sun? This one is a simple question. You should know this even before this chapter. The type of force that keeps objects orbiting other objects is a gravitational force. Which distance is the largest? The diameter of Neptune's orbit, the diameter of the Sun, the distance between the Earth and the Sun, or the distance between the Sun and the nearest star Proxima Centauri. These are completely different scales. In the solar system alone, the diameter of the Sun, big as it is the smallest of all these options. The distance between the Earth and the Sun is the next one. So if this is Mercury, Venus, Earth, obviously not the scale, this distance between the Earth and the Sun will be the next in this um, set of options. The diameter of Neptune's orbit will be the next one. So Earth, Mars, Jupiter, Saturn, Uranus, Neptune. Okay, again, not the scale, but this orbit, the diameter of this orbit over here would be the next one in scale. A linear D, which is the correct answer, the distance from the Earth to the next star is something I wouldn't be able to draw in any screen. Okay, the distance is so big that I wouldn't be able to represent it on any screen. So this one is obviously the largest of the four distances. Paper 2, question 1. Which statement is correct? A. A light year is the time it takes for light from the sun to reach the Earth. B. The planets move around the sun in circular orbits. C. The sun consists mostly of helium. And D. The sun contains more of the mass of the solar system. Starting with A. You should know that the light year is a measurement of a distance. The light year is the distance traveled by light in 1 year. It doesn't have anything to do with the position of the sun and the earth. So A is incorrect. B. The planets move around the sun in circular orbits. No, the planets move around the sun in elliptical orbits. Some of them are close to a circle, but all of them are elliptical in nature. C. The sun consists mostly of helium. The sun has helium, but most of it is hydrogen. So the correct answer is going to be D. Let's just check. The sun contains most of the mass of the solar system. That is true. The sun has around 99% of the mass of the solar system. All the other planets, moons, asteroids, comets, they account for less than 1% of the mass of the solar system. So the correct answer for this one is D. The sun emits electromagnetic radiation. The graph shows the energy emitted per second for a range of different wavelengths. So you have a graph in which the y-axis you have the energy emitted per second, and on the x the wavelength of the radiation emitted. Which row gives the types of radiation found in each region? So you have here region X, Y, and Z. What is happening over here as you go from X to Z? The wavelength is increasing. So this question is not specific to astronomy. This is a question that could be on the chapter of light. Because what you need to know is the relative position of these three areas of the electromagnetic spectrum, the infrared, the ultraviolet, and the visible light, in terms of their wavelength. And you should know that from these three, the one that have a higher wavelength is the infrared, the one that has a shorter wavelength is the ultraviolet, and in between you have the light. That's all you need to know. So the correct position is the one in which you have on X the ultraviolet, on Y the visible light, and on Z the infrared. So that one is C. Region X ultraviolet, region Y visible light, region Z infrared. Question 3. A distant star explodes as a supernova. Which statement is not correct? A. The exploding supernova forms a planetary nebula. B. The distant star is large when compared with the Sun. C. The supernova releases heavy elements into space. D. The supernova leaves behind a neutron star or a black hole. Let's start with A. The exploding supernova forms a planetary nebula. When a supernova explodes, it will form a nebula, but this nebula is not a planetary nebula. No planets are going to be formed out of this nebula. All right, no new stars are going to be formed out of this nebula. Um, so the statement that is not correct is A. Let's just check the other three. Um, and I'll do that by briefly explaining what a supernova is. All stars die. The sun is going to die in 5 billion years. But the sun is not going to die as a supernova because it is too small. If you have stars that are about 8 times the mass of the sun, the way they will die is going to be as a supernova. It will happen in a split second, and the star will explode. And it will explode as the star releases all its outer material in the explosion outwards, and the core of that star contracts to form either a neutron star or a black hole. This will depend on the mass of the star to begin with. So this means that answer B is correct. The distant star is large when compared to the sun, more than 8 times the mass of the sun. The supernova releases heavy elements into space. This happens because, like in all stars, um, they exist because of the conversion of some elements into heavier elements. So it starts with hydrogen that fuses to create helium and so forth. This goes through the periodic table, and eventually, on the moment the supernova exists or explodes, the heavier elements that you have on the periodic table are going to be formed on that brief moment. Okay, so then you have D, the supernova leaves behind a neutron star or a black hole. I already talked about this. This is also correct. So the incorrect one is A. Finally, and question 4. Distant galaxies are moving away from the Earth at very high speeds. Graph P and Graph Q show how the speed of these distant galaxies changes as their distance from the Earth increases. Then you have two graphs. One is a speed distance graph, that's graph P. Graph Q is a distance speed graph. In which row are the statements about the Hubble constant and about the age of the universe correct? What is the Hubble constant? The Hubble constant is basically the ratio of the speed at which galaxies are moving away from us to the distance at which they are from us. The faster or the further away galaxies are moving away from us, the faster they are moving from us. But this ratio is always kept constant. So this is basically a maths question. If you know this, the rest of the question is a maths question. Because what do you have on graph P? You have on the y-axis speed and on the x-axis distance. So the gradient of this straight line is going to give you what? It's going to give you directly the Hubble constant. That's the change of y, speed, divided by the change of x, distance. If you look at the other one, it's basically graph P, but the other way around. You have now the distance on the y-axis and the speed on the x-axis. So this corresponds to what? The gradient of this line. It would be basically the distance divided by the speed. So, in other words, the distance divided by the speed, if you compare this with the original expression for the Hubble constant, this is no more than 1 over the Hubble constant. And you should know also that this is the expression that allow you to determine the age of the universe. So, the age of the universe is determined by the gradient of graph Q, and the Hubble constant is determined by the gradient of graph P. So the correct answer will be B. Hubble constant, gradient of the line in graph P, age of the universe, the gradient of the line in graph Q. Paper 3, question 1. State the name of the force that keeps the Earth in orbit around the Sun. This question is simple. The force that keeps the Earth around the Sun or any object in orbit of any other larger object is the gravitational force. B. State how many days it takes the Earth to complete one orbit of the Sun. The time it takes for the Earth to go around the Sun is 1 year. How many days do you have in 1 year? You have 365. In order to be more precise, you know that every 4 years you have a leap year. So if you divide that extra, you have one extra day, sorry. So in order to divide that extra day by 4 years, this would be 365.25. But they will accept only 365 days. C. Explain why the sun appears to move across the sky each day. You should know that the sun is not moving. The earth itself is moving and is moving around its axis. And it does that once every 24 hours. That's what the day is. So the earth moves around its axis once every 24 hours. Question 2. Complete the sentences about objects in our solar system. Planets, minor planets, and something orbit the sun. So, what are the type of objects that orbit the sun? Besides the planets and minor planets, you have two options that would be that you could put here. So, you could either put the asteroids or comets. Anyone would be correct. The objects that orbit planets are called, if you look at our own object orbiting the Earth, is called the moon. So they are all called moons. Could also call them natural satellites. B. Compare the structure and the size of the four inner planets with those of the four outer planets of our solar system. So, what do you have to know about the inner planets? You need to know that the inner planets, that is Mercury, Venus, the Earth, and Mars, they are rocky. They have a rocky surface. And the outer planets, Jupiter, Saturn, Uranus, and Neptune, they are gaseous. They don't have a rocky surface. Also, inner planets are much tinier, much smaller than the outer planets. So you may add over here that the inner planets, they are smaller in size and mass, and the outer planets, they are bigger in both size and mass. Moving on, question 3. A. State the names of the two main elements found in the sun. The sun, like every star, it exists because it fuses matter. The sun is fusing hydrogen to produce helium, but still the main component of the sun is still hydrogen, and the second one is helium. So hydrogen is the first one, helium is the second one. Let me just spell helium correctly. B. The sun is one of many billions of stars that make up our galaxy. Complete the following sentence about our galaxy. Our galaxy is named the Milky Way. The distance of Mars from the Sun is 2.4 times 10 to the power of 11 meters. The speed of light is 3.0 times 10 to the power of 8 meters per second. Calculate the time for light from the Sun to reach Mars. You need to know that light, as the fastest thing that there is in the universe, still moves at a constant speed. So the formula that you need to use is speed equals distance divided by time. Solved here in terms of time, the time is going to be equal to the distance divided by the speed. Substituting the values that you have there, they are all in international systems, so you don't need to worry about that. For the distance, you just put 2.4 times 10 to the power of 11. For the speed, you just put 3.0 times 10 to the power of 8. And this will give the value of 8.0 times 10 to the power of 2, or simply put, 800 seconds. This would be around 13 minutes for the sunlight to reach Mars. Paper 4, question 1. Figure 1.1 shows the orbit of a comet around the Sun. X, Y, P, and Q are different positions of this orbit. Question A. State how the speed of the comet changes as it moves from X to Y. So you have a planet moving from X to Y. So what you need to know about this? First of all, you have to pay attention to the fact that the orbit is elliptical. If the orbit was circular, the average distance to the Sun would always be the same. This would mean that the speed at which the planet would move around the Sun would also be constant. We're going to see a little bit more about this on for a question further down. But this is not. This is an elliptical orbit. So the average distance, so the distance of the planet to the Sun as it moves from X to Y is decreasing. This means that the speed as it moves from X to Y is increasing. So here you have to write just state is a state question. You don't have to explain anything. It's just one point. And you just have to state that the speed is increasing. Explain in terms of energy transfer your answer to AI. Now you explain your answer. Why is the speed is increasing? I already mentioned part of it. It has to do with the fact that the distance to the sun is decreasing. So, for the same reason that if you drop an object here on Earth, it will increase its speed until it touches the ground. The mechanism by which the planet is increasing its speed is basically the same. Here on Earth, the object is in the speed is increasing because it's trading gravitational potential energy by kinetic energy. As the distance of the object to the center of the Earth decreases as it falls, is changing this gravitational potential energy by kinetic energy. Is the same thing here, but at a much bigger scale. The planet's distance to the sun is decreasing, so the gravitational potential energy is decreasing, and the kinetic energy is increasing. So that's what you need to write. So, as the distance of the planet to the sun decreases, its gravitational potential energy also decreases, and its kinetic energy increases. So you are ticking here the three boxes corresponding to the 3 points, stating that the distance of the planet to the sun decreases, that's one. The gravitational potential energy also decreases, that's the other one. And the kinetic energy increases, that's the final one. The shape of the orbit of the comet from P to Q is circular, with the sun at its center. State and explain the changes, if any, in the speed and in the velocity of the comet as it moves from P to Q. So, focusing on this part here alone, let's imagine that this is a section of a circle having the sun at its center. So, what would happen here to the speed? Now, if you focus on the question before, the one we just answered, here the distance to the sun is not changing. So, you are not trading any gravitational potential energy by kinetic energy. The distance is kept the same, so this means that the gravitational potential energy of the comet stays the same, and the kinetic energy will also stay the same. If the kinetic energy stays the same, then this means that the speed is going to stay the same. So the state part of this question is answered for speed. The speed stays constant. So this accounts for the state. And now the explain, because the distance to the sun stays the same. What about the velocity? You should know that speed and velocity, these are two concepts that are linked, but velocity also accounts for the direction in which the object is moving. And here the comet, despite its speed is always the same, at any given moment, it's going to, let me just take this out of here, change its direction. The size of these vectors should be the same, but the direction is changing. So this means that the velocity itself is changing. So the velocity changes because the direction of motion of the comet changes. Next question. Explain why the moon is visible from the Earth. Why is the moon visible from the Earth? What do we actually see when we look up and we see the moon? We only see the part that is lit from the sun, right? So, what we actually see from the moon is the reflection of sunlight on its surface. So, the answer is because the moon reflects sunlight on its surface. And that's the only part that we can see. B. Figure 2.1 shows some of the phases of the moon as seen from the Earth. So it starts on day 0 with new moon. Day 7 is a blank space. Day 14 is full moon. Day 22, you only see half of the moon. And then 29 is also a blank space. On that figure, draw the phases of the moon from day 7, for day 7 and for day 29. So day 7 is right in between day 0 and day 14. So what's going on over here? The moon is on its first quarter. Okay, so you have to draw a circle and it's going from new moon to full moon. So it's going to be lit only half of it, and it's going to be the opposite of that. So the part that you shade black is this one over here. Is going to be the opposite to day 22. Okay. Um, So on day 14 you have full moon. On day 22 you have the waning quarter. Is going back to what? Is going back to the new moon. That's what happens on day 29. Day 29 again is going to be a new moon. State what the phases of the moon indicate about the motion of the moon. So what do the phases of the moon tell us? It tells us that the moon is moving around the Earth. As it moves around the Earth, we can see different sides of the moon, if you will, being lit. All right. So it tells us that the moon is orbiting the Earth, and it also tells us that the time it takes for this orbit to be completed is around 27, 28 days. Okay. So state what the phases of the moon indicate about the motion of the moon. They indicate that the moon orbits the Earth once every 27, let's put it like this, 27 to 29 days. Let's actually calculate, given this information, the time it takes for the moon to complete one orbit to the Earth. So on a linear T, they say that the average radius of the moon's orbit is 3.84 times 10 to the power of 5 kilometers, and the moon's average orbital speed is 1,025 meters per second. Calculate the time period for the moon to complete one orbit to the Earth. So that would be the the time we were mentioning on the previous question. Um, we're talking about the average speed. So how do you calculate time knowing the average speed? the average speed equals the distance divided by the time. So this means that the time equals the distance divided by the average speed. What distance are we talking about? We may assume that if this is the Earth and this is the orbit of the Moon, we may assume this path to be a circular path. Actually, they mention the radius of this orbit. Okay, so if you take this as a circle, what is the distance? The distance is going to be the perimeter of the orbit. Being it a circle, it's 2 pi r. All right, divided by the average speed. Substituting now, you have 2 times pi times, what is the radius? 3.84 times 10 to the power of 5 kilometers. But then you have the speed in meters per second, meters. So we have to convert this value to meters. It's easy, kilometers to meters. You just put here the power of 8 instead of 5. So this is going to be 3.84 times 10 to the power of 8 divided by the average speed, which is 1025. Plug these values in on the calculator, and you'll have the value of 2.20, no, sorry, 2.35 times 10 to the power of 6. What units are we calculating this time in? So if you have here the distance in meters and the speed in meters per second, the time here is in second. If you want to put this in days, I'll just do it over here. The time in days, you just have to divide this value that you just calculated by the number of seconds that you have in one day. So you have 60 seconds in 1 minute, you have 60 minutes in 1 hour, and you have 24 hours in one day. Plug these values on a calculator, and you'll have a total of 27.2 days. You have to actually write down here the unit because the you don't have any unit here as an option for this answer, so you have to state the unit that you're using. I put here in days, but you could leave it in seconds.